the basics for an even and odd degree polynomial. So this time we're going to look at just recognizing even and odd degree polynomials, and then we're going to practice that. Our third video will focus on in behavior and practicing recognizing in behavior. So in this case, we're going to look at some examples of recognizing even and odd degree polynomials. So you can write part 2 as far as your title. Once you've done that, go ahead and click play. If you're watching right now, that means you've written the title down. So what I have here, and what I mean is here, this is here, are even degree polynomials. We have parent functions like x squared, x to the 4th, x to the 6th, x to the 8th, x to 10. So those are parent functions that are even degree polynomials. Now, what do I mean by even degree? Remember that means the highest power term. Well, there's only one term. The highest power term is an even degree. So this is 2, that's an even number, 4, 6, 8, and 10, those are all even numbers. And when we look at them, which we're going to do right now, we're going to notice something similar about all of them. And that's why we talk about this thing in behavior, which is our last video. So just wait for that for the full explanation of in behavior. So here we have x squared, x to the 4th, x to the 6th, and all of these other ones that I've accidentally also graphed. So let me uncheck all of those. Alright, so I've graphed all of these even degree polynomials that are right here. And I'm zooming out, and I'm zooming out, and I'm zooming out. And notice that as I get further and further out, and this guy, yeah, it goes on forever and ever. As I get further and further out, they all share a basic shape. They start here, where my arrow is, where my cursor is, and they go down, and they go back up, and they end up over here. That's what they basically do. For a positive coefficient, and again, we'll talk about this in the third video, even degree polynomials pretty much all look like this shape right here. So x squared, x to the 4th, x to the 6, x to the 8, x to the 10, pretty easy to recognize. They're even degrees, there's only one term. We're going to look at what happens when I have a whole list of terms and see how to pick out which are even degree and which are odd degree. So take notes on the basic shape and what I've just spoken about here, and when you're ready to, and when you've done that, then unpause the video and move on. So if you've pressed play, that means that you already recorded these as even degree polynomials, and you know why they're even degree. Now I want you to take down the rest of these, in fact all of these. So notice I have x, this thing, this thing, this, and this. So these 5 polynomials I want you to write down, and before you do anything else, write them down. Okay, now that you have them all written down, and there's no way you can follow if you haven't, so make sure you wrote them down. Ashley, I need you to write them down. Great. Let's talk about what I mean by figuring out which of these are even degree polynomials. The definition says the highest degree term is even. So in this number right here, 37 has the term x to the 0. This has x squared, x cubed, x to the 4th. Which one is the biggest? No, not this one. That's the coefficient. It says 10x squared. That doesn't make it the biggest. The biggest is the power. So the power is 2 here, 3 here, and 4. The biggest term is x to the 4th. And since that's even, it's an even degree polynomial. And so when I graph it, it looks like other even degree polynomials. Now let's look at this next one. How do I know whether this is even or odd? I look at each of these powers again. So I'm looking here, I have a 3, a 10, a 2, and no power. Which is the highest? Exactly, it's the 10. So this is an even degree polynomial also, because 10 is even. This 10, not that 10, this 10. So I click plot, and there it is. It also has that same basic shape. And then of these two, or of these three, which has the highest degree? Well, this has no degree, degree of 0. This has a degree of 7. This has a degree of 8. So the entire polynomial here, yes, has a degree of 8, and it's even. Now this is going to look a little different, and remember we're going to talk about this in the third video. So when I plot this, don't freak out. So you'll have to trust me on this because I can't zoom out far enough here, but x to the 8th really does make it look like this shape. So watch the arrow. Do you see the arrow? It really does, over time, make it look like this shape. See how it's doing this? So it goes up for a long way here, but then it's going to come back down. And the only difference of this term is that it's negative. And since it's negative, it starts down here and then goes down here. But again, we're talking about that later. For now, we just want to recognize them, which means we need to identify. So let's look at this next one. It's factored form. Notice that I had standard form, now I have factored form. If I wanted to find the standard form of this, I would just multiply it all the way out. All the way out. I'd have to use box, and then box again, and then use box again to get this entire thing multiplied out. When it's in factored form, I just count the x's. So I'm going to have 1x here, 1x here, 1x here, and 1x here. I add those up and I get how many? That's right, 4. So I have 4 x's, so it's x to the 4th power. Because when I multiply them all together, I get x to the 4th power. 4 is even, so it's an even degree polynomial. And let's look down here. Yeah, that's exactly right. I want to count the x's again. So I have 1x, 2x, 3x, and then another 3 x's. This is x to the 3rd. So it's x to the 3rd times this x is x to the 4th times this x is x to the 5th times this x is x to the 6th, which means that this also is an even degree polynomial. So what you should take away from this is that there are lots of different ways to represent an even degree polynomial. The way to find out a factored form is by counting all of the powers of x. So I counted 3, 4, 5, and 6 in this one, and then in this one I counted 1, 2, 3, 4. That's how I found the power and the even degree. In standard form, I just look for the highest term because it's already multiplied out. So I picked the x to the 4th here, x to the 10 here, x to the 8 here. I've spoken a lot. I want you to pause the video, do nothing else, process what I've said, and make your own summary about standard and factored form. Do nothing else until you've done that. All right, we're ready to move on now to recognizing odd degree polynomials. We just finished our discussion with all of these even polynomials. So I'm going to press that button, they're going to go away, and now we're going to look at odd degree polynomials. First we have our parent functions, x, x cubed, 7x to the 7, 2x to the 11th, and then again I'm going to have standard form and factored form examples. First, let's look at what each of these functions looks like graphed. So I just graphed all 4 of these parent type functions. And here's the line y equal to x. Here's the other functions, x cubed, 7x to the 7th, and 2x to the 11th. Remember, for now we're just recognizing them. But notice that they all have a pattern. All of these positive odd degree polynomials start here where this cursor is moving, see that? And then they go this direction. See where the cursor is? So they're starting here and then they end up here. That behavior is important, and again we'll talk about it when we get to that third part of this. For now, you need to have taken down these and note that they're odd degrees. Why are they odd degree polynomials? Is it because of the 7 here? No, it's because of the 7 power, the 11 power, the 3 power, and then here, the imaginary 1 power. That makes it an odd degree polynomial. Record that and then press play so that we can move on. So since you've already seen the part about even degree polynomials, you should be able to figure out how to recognize which one of these is an odd degree polynomial, because it works just the same way. So what you should be looking for, again, is the highest power here and counting the x's here. Be able to tell me the exact degree that each polynomial is, and of course whether it's even or odd. Once you've done that, then press play again and I'll review that information with you. So if you're watching the video, right now it means that you've written all of these down, all 5 of these polynomials, and you know which degree they are. So you know the exact number. For example, that means that you know that this polynomial is of degree 3, which means it's an odd degree polynomial. It's a degree 3 because of this 3 power here, and that 3 power is bigger than any other power in this term. So let's go ahead and review those since you've done that. This next one is degree 7 because 7 is bigger than 4 and 2. So it's a 7 degree odd polynomial. Here, you know that this is degree 1, 2, 3. So it's a degree 3 polynomial. Here, you know it's degree 1, 2, 3. So this is also a 3 degree polynomial. And in this last example, you know that it's 1, 2, plus 4 is 6, plus 2 is 8, plus 1 is 9. So this term, this whole polynomial is a 9 degree polynomial. Pause the video, making some summaries about how you can recognize the degree in factored and standard form. And when you understand that, then we'll move on to practice recognizing the degree of a polynomial. This means that you're ready to practice recognizing the degree of each polynomial, which is fantastic. So I have 1, 2, 3, 4, 5, 6, 7, 8 different polynomials. I need you to copy them down. When you've copied them, then you can press play. And as you copy them, think about this and then work through them and note exactly what degree they are, and then note whether they're even or odd. This little statement right here, determine whether the following polynomials are even or odd degree, are exactly the sort of thing that you'd see on a 1, 2, 3 type question on a quiz or exam, etc. So make sure that you have good practice and that you've thought through each of these before you press play. Furman, remember you have to actually stop the video and practice before you move on. Okay. So since you've done that, let's go ahead and go over these questions. This term right here is of degree what? Yes, 7, degree 7 because of this power. That means it's what? Yes, odd degree. This polynomial is degree, that's right Jackie, it's 2, degree 2. This polynomial is of degree, no, this polynomial is not degree 2. What you have to do, notice what I'm highlighting. You have to cover that up, and what do you see? You see an x squared, right? You see that? This is x squared. So you really have x squared here times x, that's x cubed. So this polynomial is also, or is actually degree 3. This is polynomial of degree 3. Let's move on to this next one. I have degree 2, 7, 10. So what's the degree? That's right, 10. So it's even. Moving down here, I have degree 1, 2, 3, and there's 3 there, so that's 6. So this is degree 6, and it's even. I have a 3 here and a 2 here, and I'm multiplying them, so that means this is degree 3 plus 2, so 5. This is degree 5, so it's odd. This next one, I have 2, 4, 16, 17. I choose the highest one because it's in standard form, and I get 17. So 17 is odd. I'm done. Lastly, I have, let's see, I've got to, remember these are the ones I have to cover up. So I have x to the third, x squared, and x. So now I've got to add those together. 1 plus 2 is 3, plus 3 is 6. So this is an even polynomial of degree 6. If you didn't understand any of these last ones, rewind the video, watch it again, and follow along and understand why each of these is even or odd degree and exactly what the degree is. And then, when you're done with that, watch the third part about in behavior and practicing in behavior.